So sometimes solving an equation is just too darn complex and rigorous and sometimes outright impossible to solve using algebraic methods. So what we're going to look at today is how we can use our graphing calculator to solve those really tough and nasty questions. This is a perfectly acceptable method for solving any equation on the IB exam if a calculator is allowed. Graphs are valid methods for solving things. It doesn't necessarily have to be algebraically. With a graph, however, a lot of times you're going to be approximating the solutions. We're using the graph because algebraic methods aren't going to get us to an exact value. So, some exam hints here. When you use the calculator to solve an equation, you must show a sketch and round your answers to your three significant figures. If the question doesn't ask for an exact answer, a lot of times that might mean a graphing solution might be good. If you can't see another quick way to solve, try the calculator. And sometimes questions simply ask how many solutions there are rather than to actually find them. And in a case like that, I hope you're thinking, well, use the discriminant, silly, but not all equations are going to be quadratic, so there isn't going to be a discriminant. But we could look at a picture to tell how many solutions there will be. So here we go. Solve this equation. Got x squared, and I've got a natural log. I mean, come on. Wouldn't it be nice if the natural log wasn't there? But unfortunately, it is. We're going to go to our graphing calculator. So I'm going to create a new graphing page. My old graphs from yesterday are still in here. We're going to graph x squared. Boom, there it is. I'm going to press tab to graph a new one. 3 times the natural log of x plus 2. Boom, there it is. How many solutions do you see? Well, you better be saying, well, there's 2. And you're absolutely right, there are 2 solutions. Remember, logarithms have vertical asymptotes. There's a vertical asymptote at x equals 0. So let's come back here and start to build this graph. So the logarithm looks something like that, except it's a little bit steeper. So that's 3 natural log x plus 2. And then x squared, well, that one I can graph in my sleep almost. The parabola goes something like this. So there's my sketch. I've got my asymptote of x equals 0. I've got an x-intercept here. I can go back to my graph to find that. Quadratic's easy at 0, 0. So let's go menu, analyze graph, and I want 0. Now I switch graph because I've got 2 of them here. I need to select the green one. Select my lower and upper bound, and there we have it, 0.531. Label that point. And now all that's left to do is to find the intersection points. So I'm going to be finding 2 points. I'm going to label them on the graph just like I would any other 2 points. In the menu, analyze graph. This time, intersection. That's for a lower bound and an upper bound. And there's my intersection point, 2.03, 4.13. Go back and find my other points. 573,328. So I'm done, right? And you might be saying, no, man, you're not done, because it didn't ask us to draw a graph, it didn't ask us to find the intersection points, it asked us to solve this equation. So my answer needs to be values for x. X squared, or x equals 2.03, three significant digits, remember, or x equals 0.573. And now, ladies and gentlemen, we are done. Here's my rationale. Here's my answer. That's all there is to it. So looking at this one, nothing seems funny here. Nothing seems weird. It's x cubed, x squared. Thinking, oh, maybe I can factor this. But if I get it equal to 0, all three terms don't have an x in it. And we can't use a substitution to factor. This is not going to be something that's factorable. So I'm going to jump over to my calculator and make a new graph here. So there's x cubed. Five x squared minus 2. Where's my graph go? And there we go. So I'm going to recreate this graph on my page. I'm going to find those 2 points of intersection. So in the interest of saving you a little bit of time, I'm going to allow you to find the key features here. And I'm going to just draw a quick sketch. Quadratic is there. I know a couple other points on this. And you can read these from the table. 1, 3, negative 1, 3. There's that curve. That side is horribly done. There's the sketch of y equals 5x squared minus 2. There's the graph of y equals x cubed. Now we go find the points of intersection. One of them, we label it on our graph, of course. There's the other one, we labeled that on the graph. Now I'm looking at the 0.68 saying, uh-oh, that might have more digits in there. I need to make sure that I see it. So I hover my hand over that, press Control Menu, and I'm going to change the attributes. And there we go. So three significant digits would be 0.680. We're good to go. So my solutions here are x equals negative 0.598 or x equals 0.680. And those are 2 points that we do need to label on our graph. We will give these two as ordered pairs. X equals that, or x equals that. So one more example to look at, and it's not actually asking us to find solutions. So it says find the number of solutions. It doesn't say solve. All I need to know is, well, how many times do these two graphs intersect? So I'm about to dazzle you here. Y equals e to the x. That's that graph. Y equals e to the x. And then 4 minus x squared would be this curve. And you might be thinking, holy cow, you just graphed that without a calculator. And you're right, I did, but I've had lots of practice. And I would hope that as we graph more and more things, you start to recognize the basic shape of what these different functions would be, and you can start doing some of these without relying so heavily on your graphing calculator. And from this picture, I can confidently say that there are two solutions. And that's all there is to it. You could use your graphing calculator. You plot these two, you get the points, you label your intercepts and all that fun stuff. But here is a graph that I was able to do with no calculator, and this would be sufficient justification on a non-calculated test as to how many solutions there are. So, graphing, most of it with the help of your calculator. That is all for today, ladies and gentlemen. See you on the other side.